Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to be talking about the complex plane and imaginary numbers in calculus or pre-calculus. So let's get started with the standard form of an imaginary number and then how to graph it. So an imaginary number has I. I is root -1, which gives us like this whole complex number scale where we can take the root of negatives. But what you need to know is when you get a complex number, it's just z equals a plus bi. I don't even know what z equals. It's just a variable. I'm not going to worry about that. I know a plus bi. A is a real number, and bi is like a real number attached to I. So it's just 1 plus I, then it's clearly 1 plus 1I, right? And you don't need this A here. You could just have 1I and it's still a complex number. And if you had just 2, no I, you would still say it is a complex number. It's just plus 0I. So when you graph just 2 on a complex plane, it would be different than if you were just to graph it on something else. Because 2 isn't really a point on a normal thing, but on a complex plane, it is. So on a complex plane, we graph a plus bi in the form a comma b. So if we had z equals 3 plus 3i, we would just graph 3 comma 3, and then you would label it 3 plus 3i. So you go over 3, go up 3. And then you'd be in quadrant run, and we'd get into that later in trigonometric form. Okay, so now you're going to be asked the absolute value of a complex number a ton in calculus. So you have to be able to derive it. Okay? So if we were to find the absolute value here of 3 plus 3i, that's just the distance it is from 0. You could use your distance formula, which is like root x2 minus x1 squared plus y2 minus y1 squared, and then like clearly your y1 or y2 would be 0, 0. So like x2, y2 would be 0, 0. You could do that, or you could do a triangle like I'm going to do. So here we can tell this 3, like the constant here, means how far we run. So this is a 3. Then the like constant of, well, the real number on the I is how far we'd go up or down. So that is also a 3. Now, if we look at this, we can see, okay, there's x, x. This is one of our special triangles. This is 45, 45, 90, which is x, x, x root 2. So this would be 3 root 2. And then, of course, if we wanted to say this would be 45 degrees, right? So our absolute value would be 3 root 2. And you're going to start to see that it does not get that simple. Like sometimes you don't have this number and you're like, oh, shoot. Like you can't just find this number or this number. And you're going to have to say, okay, well, sine -1. Well, you'd say like tangent -1 of 3 over 3 is like this angle, right? But then if it's another quadrant, like if it's in quadrant 2, you're going to have to do 180 minus that. So it keeps going, and we're going to get to some of that down here. Okay, now trigonometric form is, first of all, our standard form is z equals a plus bi, right? So if we write that out, a is the distance, b is the height, and then r we're saying is the hypotenuse. We're just calling that r. And then theta's our angle, like from the origin, from 0, 0. So if cosine theta, we're going to try to get like these numbers. We're going to try to solve for like a and b using trigonometry. So cosine theta equals a over r, right? Multiply both sides by r, and you have a equals r cosine theta. Then if you say sine theta equals b over r, then you multiply both sides by b, and you have b equals r sine theta. So if you just plug that in into z equals a plus bi, you get z equals r cosine theta plus r. This is r sine, and then you have that I. So ri sine theta, or however you want to say it. And then you can take out the r and say z equals r times cosine theta plus I sine theta. And that's a big thing here. Because like you might just get an angle, like down here, you'll get an angle, and it's super simple. You just plug in the angle, and you'll go back to standard form super easily. So if you have an angle, you can just convert straight back to standard form, which is just super convenient. Okay, so now we're going to go straight into a hard question. I'm not even giving you any practice. So don't expect to get it right, but if you get it right, props to you. So convert to trig form and graph, because graphing will help you convert to trig form. So first we're going to graph. Do a little graph. You just need to know like what quadrant it is. Negative 8 minus 5 root 3I. Well, negative 8 goes this way. Negative 5 root 3 goes this way. And then you could just like label it negative 8 minus 5 root 3I. Wait, yeah. We are in quadrant 3, which that will be important to know. Now, trig form, we're going to just have to find r, right? Once we find r and theta, we are doing well. So we go down here and we make our little triangle. I'm going to make it look like it's in quadrant 3. So this is theta here, right? And then this run is 8. And this, like, go down is 5 root 3. You can tell there is no special triangle here. So you're going to say, okay, what can we do? Well, since it's a right triangle, which they like always are, you can say, okay, so sine, well, you can say tangent theta. So tangent theta equals 5 root 3 over 8. And that means theta equals tan negative 1, 5 root 3 over 8. Right? But we can't just say tangent theta equals this because we're in quadrant 3. So how do you denote that? Well, if you were to say like this, like just say it's like pi over 4, right? You wouldn't just say, well, tangent negative 1 pi over 4, right? And get 45 degrees. No, you're in quadrant 3. So you'd add, like you'd go to 180 and then you'd add this same angle. So we're going to go 180 plus this. So that means theta would equal tangent negative 1, 180 plus 5 root 3 over 8. So that just means we're going to here, and then we're adding the same angle, just to put it in quadrant 3. So it's the same angle, just meaning sine and cosine will be different. So then that is our angle. And then to find the rest, we do like 8 squared plus 5 root 3 squared. I would probably do this first, actually, so you don't get this weird number. But I'll show you it both ways. So this will be 64 plus 75, and it'll equal x squared. That's like 100. What is that? 139. So x squared equals 139, and I don't believe that simplifies. So this is, so x will equal root 139. So this is root 139. And then also, if you were to say like, okay, well, theta equals, like sine theta equals 5/3 over root 139, then you'd say, okay, theta equals sine negative 1, 5/3 over root 139, and then you'd have to make it quadrant 3. So you'd say 180 plus like 5 root 3 over root 139. So it's a lot of work, but I just did it with tangent because I could. So then we just plug it in. We have theta here, and then we have our r value, which this should be labeled r. So we say z equals root 139 times the sine, times the cosine of tangent negative 1, 180 plus 5 root 3 over 8 plus I sine, like tangent negative 1 of, there's probably another parenthesis there, that's 180 plus 5 root 3 over 8. Okay, well, as you can see, we did a lot here. So when this isn't a special right triangle, you're going to have to do a lot, and that's okay. When you don't have a calculator, you're not expected to be able to find theta, right? You're just expected to say, okay, theta, like the reference angle of theta is like sine theta equals 5 root 3 over 139, right? So beta equals sine negative 1, 5 root 3 over 139. If that was in quadrant 1, you'd be good. But since it's in quadrant 3, you have to reflect that. Same thing, if it was in quadrant 2, you'd say 180 minus. Like 180 minus that. Quadrant 3, 180 plus. Quadrant 4, 360 minus, like to go down. And then quadrant 1, leave it as it is, because like 45 degrees is just here. You don't have to say, like, here's pi over 4, but here's like 3 pi over 4. You don't have to change anything when it's in quadrant 1. But when it's in any other quadrant, that's where it changes, because the signs of cosine, and like here, if you just left it as 5 root 3 over 8, that would leave it up here, which would mean both the signs of cosine and sine would be the opposite of they should be down here. Okay, so that was a long rant and a tough question, but if you need any help on it, like and subscribe first, but comment down below and I will be glad to explain, make another video, do whatever you need, because I really want you to understand this. Okay, now convert to standard form, which we end on an easy one. Like, it should be easy compared to that. 2 cosine 60 plus I sine 60. The nice thing about standard form is you can get right back. Oh, the nice thing about trig form is you can get right back to standard form when you have the angle. So cosine 60 degrees. Clearly, if we make our 30, 60, 90 triangle, right, if we say that 60 as 30, which you don't even need, then root 3, 1, 2. You know root 3 is across from like the medium angle because it's the medium number. Okay, so this is in Q1, and this is also in Q1. 60 degrees is like that, right? So we're in Q1. Okay, so both of these are positive. So it's 2 times cosine 60 degrees is 1/2 plus I like times sine 60 degrees is root 3 over 2. And then it's 2 times 1/2 plus I root 3 over 2. And then if you want to distribute the 2, you can, which would be 1 plus I root 3. A lot of times it doesn't look as pretty as this. They're not just over 2. It's like 9/4 times something over 2. And it's not pretty, so you don't have to distribute, but you could. Okay, well, thank you for watching. Again, please like and subscribe. It really helps me, and I'm really happy when I see someone like and subscribe. So thank you for watching. Leave a comment if you need help, and I hope to see you again soon.